Welcome everyone. Thank you for joining us today's Minitab webinar. Okay, topic today is correlation and regression. I'm Nur Sulawati. I'm the technical support specialist at Basic System. Basic System is an independent local representation for Minitab product and training in Malaysia, Singapore, and Batam, Indonesia. Before I get started, I have some housekeeping items. Okay, before we get started, there are few housekeeping items to take note. If you have questions during presentation, please type them into the question box in your control panel. You may send any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via your computer speaker, and then please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set as listen only mode to avoid interruption to the audio recording. So the recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, Minitab was developed in 1972. Okay, we just released a new version. We call it Minitab Statistical Software 90.20.1 in last 7 April. For those new with the Minitab, we are statistical software where everyone can use whether you are statistician or non-statistician. Minitab statistical software deliver business and predictive analytics, pair with the essential visualization to enable data-driven, value-creating decision-making. Our tagline, be better decision-making, faster performance, easier than ever, and now with a cut. Okay, so Minitab actually offer various type of analysis, which is we have for quality, let's say for MSE, measurement system analysis, we provide the gauge study, linearity and bias. It's study about the assessment of the precision and accuracy. And then we also have the control check, no limit for the basic control check. We also have like say QSUM, EMW, MA, and then we have a capability analysis. And then for the reliability engineering, we also provide the tools for reliability engineering. For process development, basically most of our customer using design experiment to be the best tools to do the new R&D. So inside the design experiment, they provide these features like say the Pareto chart means that from there you can get some which factor is significant to your predictor. And then we also have the main plot, which is if you want to know about the level for each factor, which one is an effect to your experimental. Okay, and then for business analytics, maybe today we go through for the correlation, and then also we provide the new menu for a new version. We call it the CUT, is a classification and regression tree. And then we also provide, let's say, for principal component analysis, let's say for PCA multivariate, so means that go for the unsupervised machine learning. We also have the modeling for time series. Okay, and then for the process validation, maybe you can go for the process design. We provide the box plot. We provide also for the process qualification, and then we also have the continue process validation. Okay, so this one is some organization using the Minitab. Our user for Minitab not limited to the manufacturing industry only, but Minitab will be used to others industry like services, finance, and academician. So our agenda today is before we go further, I think just we know what is the correlation, actually what is the regression, how to run this analysis, correlation and regression, and then why you needed the correlation and regression to solve our problem. For example, you have something like question like are the temperature and the viscosity cooking oil related, and if they related, how strong the relationship. So from there we build the model to do the prediction. So if let's say you want to know how strong that relationship, you need to go for the correlation. And then after you know the strongest of the relationship, whether is it positive or negative, you can go for the regression part for do the something like modeling part before you go for prediction. Okay, so after that we go for the summary. Okay, so let's go through into the concept before I show how to get this correlation coefficient. Okay, so correlation is a defined numerical by a correlation coefficient. We call it R. R measure the degree of linear association between two variables, which is maybe some others using input and output, maybe dependent, independent, maybe target or predictor, the same thing but different term only. And then the R is describe both the strength and then the direction of the relationship. Okay, the value of the R actually is from -1 to +1. And then for your information, in Minitab, we offer two differences correlation analysis, which is we have a Pearson product moment correlation, and then the other one is a Spearman rank order correlation. Pearson product moment correlation actually like say, is it weight and height have a correlate? Okay, so something like that one. For the Spearman rank, your variable should be orderly. Let's say low, high, median. So if let's say you have that kind of variables, you need go for the Spearman rank order correlation. Okay, for the strength here, which is let's say is it have a low correlation, okay, or you have a median correlation, or you have a high correlation. So basically, we using let's say 0.75. Okay, we consider that one is the high correlation. Okay, and then the direction is referred to the positive or negative. It's let's say your x positive, so means that if your x increase, your y will be increased. Okay, so if let's say negative, so means that maybe x increase, y decrease, or something like that one. So in the correlation part, you can get the strength of the correlation relationship, and then the direction, whether it's positive or negative, refer to decrease or increase. Okay, so this one is a some pattern of the correlation. If let's say your correlation is a positive correlate, so this one is we call it scatter plot, which is you do it the simple scatter plot with the x and your y. So from there you can build something like one line here, the straight line, So this one is, we call it positive correlation because it's the right thing. Okay, so if let's say this one, this pattern can be a negative correlation. Okay, and then this one is with your R equal to 0, means that you doesn't have any correlate with X and Y. Okay, and then this one is non-linear correlation. Okay, non-linear relationship between X and Y. Okay, linear means that you can get the straight line. Okay, so this case you cannot get the straight line. Okay, so that's why it's R squared. You need go see the scatter plot, which is referred to no relationship or refer to non-linear relationship. Okay, so I think I go to the Minitab. Okay. Okay, so for those are new with our product, actually this one is the new interface for Minitab 19.2.2.1 version, new version, which is in this interface we have let's say we have navigator here, and then here we call it the output pin. Here is a worksheet. So basically, if let's say you want just go for the data only, so you go here, is you can see that the worksheet only. If let's say you want have the output pin, so you go for the output pin, and then you can go for the both side. Where there is a output pin and here is worksheet, or you don't want is a navigator. Okay, so this one is the new layout, the new interface. We call it, this one is a single interface. Okay, so you can zoom in, zoom out. Okay, so you can zoom in, zoom out for this. Okay, and then for the menu side, I think it's not really differences between the old version. Okay, but some menu we customize. Okay, for example, before this we have option, so now we in option in this file menu button, in the edit part, and then for the data transformation, which is you want to do splitting data, you want to merge data set, you want to do the scatter data set, you want to record your data. Okay, and then we have calculator, because Minitab, the function is a column based, which is you cannot insert the formula in this cell. Okay, so that's why we provide the calculator. And then inside the calculator, if you are from the academician, maybe it's reliable for you. We have a function like resampling. Okay, and then we have a step menu. Okay, so all our analysis part inside the menu, step menu, which is we have basic statistic from the hypothesis testing with the one sample test. Okay, and then we have ANOVA. Okay, we have regression. Okay, so today we just play around with the basic statistic, which is correlation, and then go for the regression, which is fitted, and then we have a fit regression menu. Okay, so the rest, if let's say you coming from the R&D side, we have DOE. If you coming from the production side, maybe you can go for the control chart. Okay, in the side in quality tools, we have a Pareto chart, we have a capability, we have case study here. Okay, then we have reliability, and then this one is for information, is the new menu one. Okay, it's a predictive analytics. So we have a cut classification and cut regression type. So if let's say you want to build a graph, you can go for the graph pick. So we have a scatter plot, we have a histogram, we have bubble chart, okay, bubble plot, we have a 3D scatter plot. Okay, so it's this one is the how for the new updating. So whether it's want to checking your Minitab status right now, is it what type of version I use right now, so you can go for the help and then you check about the Minitab. So they appear here. So which version? So I'm using the Minitab 90.20.20.1. So you can check by your own. Okay, after this maybe. Okay, so let's go. We go for the main purpose here. So we have one case study here. Okay, one case study here example. Okay, a manufacturer supply 3 types of valve for industry motors. The manufacturer carry a line of the valves Okay, the manufacturer is specifically interested in the performance of the HLS belts. In particular, they would like a prediction for the expected hour of variation, which is they collect the data by speed, is average operating speed of equipment, RPM, in the RPM, and then for the hours is hour operation until belt show the sign of the wear. So I go directly to that data set. Okay, so this one is our data set. Okay, so which is we have the speed here, and then we have the hour here. Maybe speed is an input, hour is our output, or maybe it's a dependent, independent. This one is a dependent. Maybe you can call it is this one is the factor. This one is the your response. Maybe it can be a predictor. This one is the target. So same meaning, okay, but different term. Okay, so how to get to do the correlation? So go for the stat, basic statistic, go to the correlation. Okay, so you choose speed and hours. Okay, and for the new version, you can get the graph menu here. So which is this one is correlation interval, and then we have the lower or we have full. So I just pick with the lower left only. Okay, click OK. And then you have option here, which is if you want to using Pearson or you want to using the Spearman. So for this case, because this case only the number, okay, so not the rank order. So we just proceed with the Pearson correlation. Click OK, and then click OK. Now you get the correlation. Okay, for the new version, we not provide this scatter plot. Okay, sorry, for all version, they not provide this scatter plot. For the new version, they provide this scatter plot with this R, coefficient correlation. So this one is, we call it coefficient of correlation. Okay, for the new version. So I go back, redo again, go for the basic statistic, go to correlation. So you choose what is you want in here. So we have a speed and hours. So we go for the graph. This is just only for say with the lower left, and then the correlation interval. So click OK and go for the option. Since that one is the not the orderly, so we choose the Pearson. Click OK and then click OK. So you get the metric plot of the speed of hour. So now we need to do interpreting for this result. So for example, here we have the R here is a negative, means that speed and hour have a negative relationship, which is speed increase, so hour decrease, or is speed decrease, hour can increase. So this reflection, because this one is a negative correlation. So the strongest of this correlation, which are 0.8, is quite higher. Okay, means that is speed is most correlate with the hours. Okay, so if let's say we go to this one, okay, this one, okay, so which this one, the correlation coefficient is negative 0.801, indicate that hours and speed measure have relative strong negative linear association. Okay, since our linear relationship exists, it should be investigated further. So maybe you no need to stop here. You may go for further one. So if let's say you want to go further one, they are, we call it, you need to go for the regression analysis part. Okay, so for this portion, you just know now you have a correlate with the speed and hour. So what the next step you need to do, you need to go for the regression analysis. Okay. So what is the regression analysis? Regression analysis generates an equation to describe the statistical relationship between one or more predictor. Okay, predictor which is your X, and then the response. In mathematical equation, this one is equation refer for the regression model. So let's say it's a simple one. So you have a y equal to b naught plus b1 x1 only plus with the absolute. This one is a random error. So basically, linear regression usually use the ordinary least square estimation method. Okay, so it's general equation. You can get this like y is your response, x is your predictor, your x. Okay, your beta naught is intercept, and then b1 until bi. So it's a model coefficient for this one. Okay, so in your mind right now, regression is generate an equation. So for what? To do the prediction if you have another new observation. Okay. So in regression, we have many types, but depends on the type of your response, your y or your target, which is your y, whether it's a continuous or discrete measure. Okay, so continuous means that your y is a numerical number. Let's say it's a weight, length. Okay, and then for discrete measurement, let's say your y can be a binary. Let's say accept, reject, or your y can be ordinary. Let's say low height, low, medium height, or discrete. Maybe can be like satisfaction, satisfied, very satisfied, not satisfied, something like ondori. Okay, and then for your y is continuous, you have let's say you have a you can go for the simple regression if your x only one x. Okay, if let's say you have more than two, okay, more than one. Okay, so starting with the x, you have two predictor, so which is unique, go for the multiple regression. Okay, so if let's say you have a curvature, like you have cubical or you have quadratic relationship, so you need go for the non-linear regression. Okay, so let's say if your x, your predictor, more than number of sample, so you can go for the partial least square. So this type of regression is available in Minitab. Okay, so if let's say your y now is discrete, whether it's pass or fail, accept or reject, so we can go for the binary logistic regression. Okay, and then if let's say your y is the orderly, let's say low, medium, high, so you can go for the ordinal logistic regression. Okay, if let's say you have nominal logistic, you can go for the you have three, but not the order one. So let's say it's type of the defect, so you can go for the nominal logistic regression. Okay, so let's say your y is let's say even, count of even, so you can go for the Poisson regression. So if let's say we go for further for this regression, I think it's not enough for 1 hour. So today webinar just focus on the simple regression only. So maybe after this, maybe we can go for the others type of regression. Okay. So what is a simple regression? Simple linear regression examines the linear relationship between two continuous variables, which is you have one y and one predictor, one x only. Okay, regression provides the line that best fit the data. Okay, the line can be used to examine how the response variable change as the predictor variable change. Okay, predicted the value of the response y for any predictor of x. So for example, you have a question like, how does processing temperature related to the mean hardness of the steel? Or maybe what is the predictor mean hardness of the steel if processed at the particular temperature? So, or maybe you have a question like, what is the expected mean increase in hardness if the processing temperature increased by 100 degrees Celsius? Okay. So, but for information, since regression analysis is statistical analysis, so we have a assumption. to fulfill or to validate this analysis. So you need to go for this assumption to confirm that your analysis is valid or verify our assumption about the model error term. So you need to fulfill this assumption. Okay, so we have a first one, you need to make sure your residual plot is anomaly distributed. Residual means that differences, okay, between the observation value of the response and the value predicted by the model. So from there, from residual, you need to check the normality distributed. You need to check the constant variance for all fitted value, and then you need to check the random over time. So never mind, Minitab will generate directly to you. No need go one by one. Okay. So I think I go directly to the Minitab side. Okay. I use the same case study here, which is the hour and speed. Since in the correlation part, we know now they have correlate with the speed and hours, so have quite strong, which is 0.8. Okay, between speed and hours. So that's why we want to do the regression to get the model first before we go for the prediction. So based on this case study also, the aim of this case study, they want to know about the prediction. Okay, so that's why we need go for the regression first. Okay, so where you can get the regression, go to stat, go to regression. Okay, so if let's say you see here a lot of type for the regression, but I already explained it. What is the regression, nonlinear regression, okay, please study. Okay, binary, when to use in the binary, when to use in ordinal, when to use in dominant logistic. Okay, but today we focus on this menu only. So fitted line plot. Okay, so fitted line plot is most for the simple regression, just only x. You have only one x here. So our y is hours, our x is speed. Okay, and then we go for the type of regression. Okay, if let's say you go for the graph, you can go for the graph, but I think I just proceed with this first. Okay, click OK. Sorry. Okay, speed. And then click OK. Okay, so I get this one. So I do again, go to stat, go to regression, go to fitted line plot. So we have a response hours, your predictor is speed, and then click OK. So now you get the regression. So this one is the output for regression. The most important in the regression side is your R squared. Okay, and there are registered. So R squared means that they explain about this one. Okay, so this one is R squared is 64%. It's quite high. Okay, it's a good, it's quite high because some researchers say that 0.75 is quite high relationship. And then go for the analysis of variance. So you can see that this one is significant since 0 is smaller than 0.05, and then we get this line. This one is a we want to this one is the equation. Okay, so this one is we call it fitted line. So fitted line is that hour equal to 2298 minus 0.4402 speed. Okay, so for the new one, they provide the R squared in this fitted line. Okay, so in this regression, this one. So now you think that this one is the good one. Okay, the good model, the good equation. So you go back to the dialog box again. Okay, you go for the graph. Now you need to check the assumption. Okay, check the assumption like normal distributed. You need to check the constant variance for a fitted value, and then you have the random over time. Okay, so you need go one by one. You want to generate to you one by one. Okay, option, or you want to in one graph, you have 4 things histogram, normality plot, you have residual versus fit, residual versus order. Okay, depends on you, but I just proceed with this one first. Click OK, and then click OK. Now they provide this assumption. So based on this assumption, is quite normal. So the first assumption is fulfilled. Okay, this one is no constant is okay. Okay, fitted one is that this one is a refer for this one. Okay, support for this one. And then this one is a random overlay. So just make around the 0 portion. Okay, or I go back to the dialog box again, go for the graph. You just put in the 4-in-1. Okay, and then click OK. Maybe it's too easy to do the reporting purpose. Okay, so whether you want to using splitting for each assumption, or you want to one graph only to see the assumption. So this one is how regression can do for you. So now we get this equation. Okay, but for information for regression fit, we have a 2 method. Whether you want to using stat regression fitted line model, okay, or you can go for the stat regression, go for the regression, you choose fit regression models. Okay, which is you can see that the dialog box inside there, you can include more than one. Okay, for example, here is response. Our continuous predictor is speed. Okay, so we a lot of information. Okay, for example, we have model here. So if let's say you want, because this time just only one, okay, just only one, so you cannot see all this predictor. So maybe if let's say you have more than one, so you can go through for the interaction side. Okay, so click OK and then click OK. So you can get the same thing. Okay, the same result. Okay, for this one. So also you can get the regression equation. Okay, you can get more intuitive. You can get for the coefficient for each terms, and then you can get for the model summary here. Okay, and then you get the analysis of variance. The P, rely on the P value here, and then you can get for the fit and diagnosis for unusual observation. So this one is a two-way. Whether you're using regression, fitted line plot, or go for stat regression, go for digression, fit regression model. Okay, in the fit regression model also they provide the assumption. Go for graph, you choose 4-in-1, click OK, and then click OK. Okay, so click OK. But for your information, for the new version, they include some like, go for the back to this one. Okay, fit regression. So okay, regression validation portion, but I think I need to explain to another webinar. Okay, not in this session. Okay, for this one. Okay, after you get this equation, the main purpose you want to do the prediction. So I go to stat, go to regression, go for the predict. Okay, go to predict, go back, stat, regression, go for the predict. Okay, so go to predict. So now I have the new speed here. I have the new speed here. I have new state 3250. Okay, and then I click OK. So now your new speed, okay, your speed is 3250. So now your hours is 867.955, or you want to in the confidence interval between 827.57 and 908.331. Okay, this one is a predictive interval. So this one is how to do the prediction. So you go to the stat you go for the regression. A regression, you choose the predict. Okay, if let's say you not build the models, so this function cannot be using. Okay, so let's say you see here is you cannot go. So that's why you need have the fit model first. Okay, and then for information, Minitab will capture the last part for the fit model. Okay, to do the prediction. Okay, to do the prediction, go for the regression, go for the regression models. Okay, sorry, go sorry. Okay, go to predict. Okay, so go for the factorial plot. Maybe you want to build the factorial plot. Let's pick here. It's not something. Okay, so the main plot here. Okay, so this one is basically we're using for DOE purpose because we want to find which level for in the factor is most significant part. Okay, so go for this regression, go to predict. So to want to do predict. Okay, so they capture the last model. So you can see the model here under this one. Okay, you can store the predictive, you can store the confident. Okay, you can go for the result one. You don't want, you unclick. So you can have the option here. This is you want to not the 95, maybe 90.9 confident interval. So you can manipulate in this one. Okay. So I think for today's session is good. Good. Okay. Okay, so maybe I go for another example. Okay, go for another example here. Okay, so do something. Okay, a material engineer at a furniture manufacturing site want to assess the stiffness of the particle board that the manufacturer used. The engineer measure the stiffness and the density of a sample of particle board pieces. The engineer used the simple regression to determine whether the density of the particle is associated with the stiffness of the board. So I go to the data set. Okay. Okay. Go to first, we go for the basic statistic, go for the correlation. Okay, so this one, select all this one. I just proceed with the okay. So now we get this one. Okay, so quite high, but now for this second example, you can see that is a positive correlation. Okay, positive correlation. And then the strongest of this correlate is 0.9. It's quite high. Okay, rather than the first one. So now we need go for the build the model. So go to stat, go to regression. I think using the fit regression model. Okay. So for our response is the stiffness, continuous extensivity. Okay. So for the graph, maybe I go directly. The first one, okay, okay. Okay, so this one is our regression equation here. Okay, so this p value is significant. The R squared here is quite higher. Okay, the p value is also significant. Means that is a linear regression, and then this one is density is need include into our equation here. Okay. Okay, you can see that this one is better. Okay, so this one is how to do the correlation and regression. I think this one is the starting point to you to see another side after you see that, and then you go for SPC part already your process in good condition, stable and control it. So maybe you can go for another step, which is the prediction. But prediction we starting with the correlation first, because just only rely on only one X only. Okay, so I think I have another one is want to see the correlation if let's say you have more than one X. Okay. So it's this one. You want to assess the correlation between each cavity. Cavity 1, cavity 2, 1 with 3, okay, 1 with 4, and so on. So it can be applicable to the correlation, but you just can access between two variables only. If let's say go for the correlation, go to stat versus state correlate. So you need to choose all this, select all, and then graph. Maybe just only one left. Okay, click OK, and then click OK. Okay, so you can communicate one. So the one, so you can see that the correlation with this cavity 1, cavity 2 with the cavity 1, okay, 3 with 1, so this one, so you can see that this one, okay. So if let's say you're using the old version, maybe you cannot get directly from this correlation dialog box. Maybe you can go for the first thing, you can go for the graph, scatter plot. So you choose the simple, click OK. So for this one, click OK, and then you click OK. So you get the same scatter plot, okay, but different layout. But they not provide you the R squared. The R coefficient correlation, okay, and then you can get the scatter plot. Before this, we go like direction, okay, go for the scatter plot. Okay, so for the old version, but now you can see that the differences between old version and then new version. So easy for you to see the whole thing. Okay, the whole thing for this one. More intuitive. And then they provide something like this one, correlation. So which one is the highest? You find out which one is the positive correlate between cavity 1, cavity 2 is quite higher, okay, in the positive way. Cavity 1 with the cavity 6 is a negative, but it's so lower, 0.1 only. Okay, so you can manipulate this one because this important part, if let's say you go for the other stages, we call it multiple regression. Okay, so you need to consider all this kind of the correlation. Okay, okay, for this. Okay. So applied correlation and regression can be a great decision-making tools because you can predict the average outcome given the input value. Okay, if we have more than one predictor, we have another way to build the model by using multiple regression or classification regression tree before we do the prediction. But this will cover in the other session webinar. So if let's say you have more than one X, you can proceed with the multiple regression or classification and regression tree. Okay. So any question, if you have question, please type them into the question pane at any time. Okay. You show on the P chart because this one is the old version. Okay. If let's say you follow me with the old version, so you can get only the P chart. But never mind, you can go for the scatter plot first. Okay, you can see the scatter plot because it's important when your R equal to 0, which is they will be a non-linear or non-linear relationship or non-correlation between two variables. Okay. Okay, what is the differences between fitted line plot and then regression? Okay, fitted line plot means that you have a line, okay, So regression means that your line, that line too, we call it that regression. Okay. R squared is referred to the explanation, your x into your y. Okay, your x into your y. So how many percent your effect, your x into the your y. Okay, so I think I have one. Sorry, I not go through for this result. Okay, okay, so this portion. Hmm. Okay, so for this one is a very okay. So this one is a linear relationship, and then explain it 64.1% of the variation in hours. Okay, and then since the p-value is significant, speed has a significant linear effect on the hours. Okay. Uh, okay. Okay, normally, industry using 0.75 is the highest one. 0 are equal to 0 is non-relationship. Maybe R 0.1 until 0.5 is something like low. So above 0.5, we consider that the medium correlation. Okay. Okay, how we can do, how do we use the 4-in-1 chart? Okay, so I will show. Go back to this one. Go to stat, regression, go for the fit regression models, go for the graph, you choose the 4-in-1 graph. Okay, 4-in-1. Okay, and then click OK. So now you get the 4-in-1 graph. The same thing, you need go for the normality, normal probability. You need to go for the versus fit random, okay, constant, and then randomly your residual. Residual means that differences between the observation, days on observation, minus with the value predicted. So this one, so you can get the residual. But if let's say you want not the residual, go back to this one. You can go storage. Okay, so you want to fit here. Okay, you can get this one. You can store. Okay, residual. Click OK and then click OK. So they restore for you. So they fit line. So which is this one. Using this equation, you get this one. So this one minus this one, you can get this one. So this one definitely minus this one, you get this one. So this one is we call it residual. So from there, they provide this one, normality versus freezes and the versus order. Okay, this one is a crucial part to do this assumption. Okay, for the assumption. How you should decide whether my analysis is effective or non-effective? This one is something like depends on your objective. Is it effective or not? And then from your objective, you can choose it the right method. Okay, the right method. Okay, sorry. I think in Minitab we have another way. Is we call it assistant to maybe have something tips to you before you go further. You go for the regression. Okay, so what is the number? So you can see that one x variables, you have a 2 or 5 variables, we consider that this one, and then go for the simple regression. If let's say only one, okay, for example, sorry, okay, assistant regression, okay, go for the simple regression, your one, okay, your x is big, okay, you click okay. So they give it this, okay, so okay. So maybe is one is how to interpret things, because they provide you is the relationship between x and y. Okay, the relationship between this hour and this significantly p less than this one is a significant. Okay, so this one is a fitted line, and then they provide you the comment here. Okay, and then they have a model selection report. So R squared also thing, and then they have a dynasty report, seems like assumption. Okay, so this one is a predictive report, and then they have a report card. The is amount of data. This one is unusual data, normality, or model fit. So this maybe will help you if let's say you the first time you want to use in the regression part. So if let's say this one, you can manipulate it, just double click, and then you want to see the comment here. Okay, so for example, it's prepared by, okay, and click okay. Or you can add something like this one, and then go to send to PowerPoint if let's say you want to do the presentation. So, okay, so you get this one to send to the PowerPoint. Okay. Any question? Others question? Okay. If let's say no, okay, how to further reduce the regression percentage? This one is applicable if let's say you're using the multiple regression, which is you can manipulate the terms inside there. Is let's say you have a 5, you remove one predictor, and then you maybe you want to access the interaction, so they can be something like effect to your to the percentage to you. Okay. Okay, maybe if let's say I cannot answer in this session, I will email to you. Okay. Okay. So if you want to try or buy the new version or new one for you, so you can visit our website www.minitab.com or www.visit.com, or you want to interest, you can contact us to sales@visits.com or minitab@visits.com. And then if let's say you want to know about our latest upcoming event or our tips and tricks, so you can follow our social media, Facebook and link Minitab Malaysia and Singapore.